I've mentioned before that OpenGL has a transparency feature, and so, yeah, I think now's the time to learn to use it. It does turn out to be useful for a lot of things. Um, One thing to recognize, though, is it's not really transparency. It is blending. Okay. Now, what's the difference? Transparency is actually a subtractive color process. Now it's like looking through the cellophane, like we talked about when we talked about subtractive colors. Instead, what it's going to do is it's going to blend the colors. Do we care? Yeah, I suppose you could care if you were doing a game and you wanted to make it look like somebody really was looking at the outside world through a stained glass window. See, what makes it subtractive is if I'm looking through say, a red window at a blue object, I'm going to see black because the object is blue because it can only emit or reflect blue light, and the stained glass window is red, which can only transmit red. So if I can't transmit the colors I've got, I'm going to see black. Whereas in OpenGL transparency, which is really blending, a red object or a blue object and a red piece of stained glass would produce magenta. Okay, now again, do we care if we're trying to really emulate that in a game? And you can write a shader to do this if you really care. Most of the time, though, when we do OpenGL transparency, we're trying to see something with an outside context. You saw the picture of the transparent heart before. We wanted to see the inside, the chambers of the heart, but we wanted to see where the outside was. And there's a picture. Let's go to the picture at the end. And then there's this, which is the same sort of thing. Here, we want to see the bone structure, but we want to see where the skin is. We want to see it in an outside context. And so if that's why you're doing transparency, then yes, this will work fine. Okay, and here's an example of it. Transparent green object, solid opaque red object, and what you see through there is yellow, whereas you really should be seeing black. Okay, but how do you do this? First of all, when we say color 3F, we're actually calling color 4F with an alpha value, which is the transparency value, an alpha of 1. Okay, so color 3F is really RGB, comma 1. But if you're wanting to specify the transparency factor, use color 4F, and the fourth argument is 1 or alpha. And very shortly, we're going to be talking about lighting, and we're going to have calls called GL material, and instead of doing color, you would do color and alpha like this. So anyway, if you're doing colors, you do color 4F. And if you're doing lighting with materials, you do material FV. An alpha value of 0 means the object is completely transparent. Okay, by convention, alpha equals 0 means transparent. Not terribly useful. An alpha of 1 means the object is completely opaque, also not terribly useful. And so the real fun comes as you vary alpha, something greater than 0, something less than 1. This is the alpha blending equation. And so you take the existing color, the old color, and you blend it with the new color using alpha and 1 minus alpha. And so I sort of think of this as like a dial where you are cranking up the alpha, but at the same time you're cranking up the alpha, which means you're getting more and more of the new color, you're getting less and less of the old color. And again, alpha equals 0. Well, if alpha equals 0, that means the new color is not there, and we get nothing but the old color. Alpha equals 1 means the new color is completely there, and we get nothing of the old, which again isn't terribly useful. Okay, so because typically you use this as you're drawing inside stuff and sort of a transparent outer context, you draw the solid things first. If you draw the transparent things first, then you're not going to be able to get the kind of blending you want. Okay, so you draw the solid things first, the inner things. Then you enable color blending. And remember, we've seen this GL enable in several other uses before. Now we're turning on blending. OpenGL doesn't want to tie up graphics rendering time for things it doesn't need. So by default, the blending is off, and you have to turn it on. Now, make the Z buffer read-only. I'm going to ignore this for right now, and I'll come back to it about why we did that. Okay. Then you tell it what blending function you would like to use. And there's a whole bunch of them. However, the one I think that actually makes sense is this one, which is the equation on the previous page, is alpha times the new color plus 1 minus alpha times the old color. There are others, but this is the one I think makes the most sense. Now you draw the transparent things, and now you disable the blending. Okay, now what is it about this depth mask? Well, if you have one solid, or if you have any number of solid objects, but you only have one transparent object, you don't need to worry about that. You can just blow that off. But here's what's going on. Let's say that we have two transparent objects like that. Okay, and let's say the eye is out here looking at them. And we're going to call these things A and B. Now, if you were to draw these in some specific order, like if you were to draw A first and B second, then everything would be fine. But if you were to draw B first, so let's see what happens if we draw B first. So we draw the solid part. Yep, that's a given. Now we draw B first. That's great. It blends with the solid thing. But the problem is the Z buffer does Z buffer things even for a transparent object. So now the Z buffer thinks this is the most, or this is the closest Z value that's been filled. Now we go to draw A, and well, because this is our closest Z, A doesn't get drawn. A gets Z buffered out. Okay, that's why at times you need to do this. Basically what this does is it disables the Z buffer. Okay, now if you knew for sure you were going to draw A first, the inner thing first, well, okay, that's a lot nicer because now this it only thinks the Z buffer is this deep and B will get drawn. But the problem comes is, what if A and B are not nice concentric things like that? What if what if we have a solid thing here and we have kind of a mix of A and B like that? And okay, now we don't know. I don't know whether we're drawing the outer thing first or the inner thing first, because at times A is outer and at times A is inner. So anyway, if you're doing two transparent things, then we typically disable the Z buffer. And of course, when we're all done, we want to re-enable the Z buffer. And so this is just a nice example. Okay, so if you set alpha all the way one way, okay, we can not see the outer layer. We can only see the inner layer, which is the bone. If we set it the other way, we can't see the bone at all. We can only see the outer layer. And if we do 0.5, 0.5, well, then we can see both. And that's typically the way we use OpenGL transparency.